Welcome everyone to the Data Science and Data Engineering series. Today we have Mariah. Mariah Martin Shein is the Director of Machine Learning at Vubble. It's a technology-based company based out of Waterloo and Toronto. She has considerable experience in working as a data scientist and as a software engineer, where she's worked on a number of important projects, some of which she'll be talking about us today. She has attained her master's in mathematics from the University of Waterloo, and today she'll be talking about how to categorize and recommend information videos. Thank you, Mariah. Thanks for joining us.
Thank you. All right. I'm Mariah. I'm the Director of Machine Learning at Vubble. And today I'm going to talk about popping bubbles, or how to categorize and recommend information video. Okay, so what do we do at Vubble? Well, we're a small technology company, and we have a team of data scientists, software engineers, and journalists. And together we curate, assess, and distribute personalized solutions for information video. So our customers are media and education companies, and we help them distribute and organize their video. And our system uses a blend of artificial intelligence and human wisdom. So we definitely want to make the best use that we can of both machines and humans for what they respectively do best. Okay, so you might be wondering, what is information video? Basically, it's not entertainment video. So with entertainment video, this is like basically any TV shows that are fictional, Netflix shows, all the streaming platforms basically are entertainment providers primarily. And entertainment video has a pretty good ecosystem built up around it with like all the streaming services that are out there. In contrast, information video, like news and education type video, doesn't have the same sort of structure that entertainment does. So this was a really good area for us to work in and to provide sort of the background structure, the metadata around videos that information video just doesn't have. So yeah, basically it's news and education videos, anything that's informative, factual, ideally accurate and true. So just backing up a little bit, I want to talk about some of the issues that exist with current information distribution. You're probably familiar with them. They're pretty big problems, and currently society is looking for solutions to these. So two examples. One is polarization. So this is basically often thought of in a political spectrum kind of way, like the left versus right, where people on either side of this political spectrum their views are becoming less and less similar, and there's more animosity between both sides. And this is really a difficult problem to have in like a functioning democracy, because we want collaboration, ideally, in order to actually get things done as a society. So polarization is often, nowadays, it's kind of driven by the existing structures of algorithms for how we see content. So for instance, Facebook, that's a pretty big problem right now, where on your Facebook feed, that's very manipulated by Facebook in order to make sure you're engaging with Facebook and clicking on their ads. And the best way that they've found to do this is by not necessarily giving you the best, most accurate information, but instead giving you the most inflammatory, not necessarily sensationalized, I guess. Sensationalized news is what drives clicks and engagement and shares, and that is basically what keeps them making money. But it's not really the best when it comes to having people who are well-informed and good at critical thinking. So polarization, you can also think of it as people get trapped in bubbles. And that's where the title of this talk comes in, popping bubbles, because we want to, one of our goals at Vubble is to build algorithms that help people pop their own bubbles and see viewpoints that they wouldn't normally seek out for themselves, or that wouldn't normally be presented to them from an existing algorithm like in social media. A second problem is misinformation and disinformation. So when the pandemic started, the World Health Organization also declared an infodemic, not just a pandemic, but infodemic. Basically, the issue is in a pandemic kind of situation, there's a lot of uncertainty. And when people are uncertain about how to keep themselves safe, how to keep their loved ones safe, how to not catch a disease, they want to seek out information. It's natural. But that means that when we don't know good information, when it's like the beginning of a pandemic, it's really hard to get accurate information to people, and either we don't know the right answers, so that's kind of misinformation. It's not deliberately bad, but it just might not be the most accurate, just because we don't know yet the true information. Or disinformation. Bad actors can be deliberately spreading conspiracy theories and deliberately bad information in order to take advantage of people. So misinformation and disinformation are a pretty big problem, and we want to develop algorithms that help people recognize and identify misinformation and disinformation in order to make sure that they're getting good information and that they can assess it for themselves. So we have a number of values at Vubble. 3 that I particularly use in driving decision-making and development of algorithms are here. So first of all, there's explainable AI. There's a lot of talk about explainable AI these days because there have been a lot of issues with bias and just not understanding why various AI systems are producing the results that they are. So we don't want to just trust that the black box is going to produce good output, but we want to make sure that we understand and that just general people who are using our systems understand what our AI is doing. So explainable AI is one of our values. Second, privacy is really important. Just people who are using our systems deserve to know what information about them is being collected, what's being tracked and what isn't. So we always try to anonymize everything that we possibly can, and not just collect. We don't want to spread a wide net and just collect everything in the thought that maybe in the future we'll use it. We always want to be deliberate about what kind of data we're collecting and why. And finally, lifting critical thinking. This one is the popping the bubble, helping to provide strategies that help people recognize what is good information, helping them critically engage with media to make sure that they can see if it's good, see if it's relevant, and or if it's not. So these 3 values are what I particularly use in my work at Vubble. Okay, so I'm going to talk about the Vubble system. I basically divided it into 4 parts. So we use information video, so we've got to get that from somewhere. So the first step is the importing step. So we collect videos from all sorts of news organizations, just like CBC, CTV, American ones, PBS, UK, Channel 4, New Zealand, Australia, all over the world, public radio or public media, because we need video. And as well as YouTube, because there are some really good YouTube channels out there, especially educational YouTube channels. And there's some really good journalism happening on YouTube as well. So we pull from all sorts of diverse sources, and we pull that all into our toolbox, which is our collection of videos. So in the toolbox, we have a team of journalists, which I'll also call editors, and they look at each video that we pull in and assess it for the quality, its credibility, and as well as general categories. So these are things that, if we think about it in the entertainment sense, all the videos are always associated with lots of metadata, the genre, the actors, where it was filmed, all of this stuff. This doesn't come along naturally with the information video, so we're adding this in as in the second step of our process. And we have AI that we are developing that's going to support our journalist team in categorizing and assessing these information videos. Third is recommendation. So we clearly want to improve user experience by providing a personalized experience because people are different and people have different wants and needs, but we don't want to contribute to the problem of polarization, obviously. So we want to be able to personalize recommendations, but also provide some potentially surprising or serendipitous recommendations as well. And finally, we have to distribute these videos because otherwise no one will see them. So we have a number of products that we use to distribute these videos. And basically, we provide the framework. So we have a discovery box and a smart email that our customers who are news and educational organizations, they put on their website and share the videos through these products. And I will do a demo of the discovery box later on. Okay, so let's talk about the data set, because we have a really impressive and unique data set, which I'm very excited about. So it's over 50,000 videos currently, and this has been gathered over quite a few years. Every day, we pull in more videos from our various sources, and we have our team of editors who go through and label them. And we have, as possible labels, we have over 500 categories. So these include things like the topic of a video, so whether it's science or geography or politics or business, basically all of those possible topics are given as labels. We also have, we can give geographic information, so if a video came from a particular country, we can add that in as well. And source as well, as so where the video came from in terms of the publisher. We also do, we have 3 additional kinds of information that we add as metadata. So first is the Vubble credibility meter. So this is a criteria that we've developed as a company that basically give an indication of how credible or trustworthy a video is, and there's a 5 category scale, and so they get scores in five categories, which altogether give an overall credibility score. So every video has, well, every information video has one of these credibility scores. We also have a tone indicator for every video. So this is basically whether it's happy or light versus whether it's kind of heavy, angry, sad, basically that sort of sliding scale. And this can be used for a number of ways. It can be used as part of the distribution of the videos, and it can also potentially be used by advertisers, as much as the ad-driven model is a bit dangerous because that can lead to polarization. That is kind of one of the only ways to make money currently with video distribution. So basically, some advertisers might want to only have their product displayed in front of happy videos. So with this tone indication, we can match those things up. And finally, we keep track of persona and personality indicators. So this is basically our editor's assessment of what kind of personality, what kind of person would this video appeal to? So we have, every video has a score on the Big 5 model. So you might be familiar with that personality model if you know about the Cambridge Analytica controversy. But we're trying to use it in a way that is more friendly to the users and in an ethical way. And we also, so we have Big 5 personality as well as persona, which is basically kind of types of people, so geeks or nature lovers or politic junkies or that sort of classification of people that we also mark down for every video. So there's a lot of metadata associated with all of our videos. So it's a really rich data set. And so basically, what can we do with this data set? Clearly, our team of journalists has put in a lot of time and effort and continues to work on assigning categories and assessing the credibility of each video. But this data set is also a really great training set for machine learning algorithms like deep learning in order to do the video categorization automatically. So we've actually started a research partnership. Actually, we've had it for a few years now with Seneca College. Dr. Vida Mohavedi has been leading the research at Seneca College along with us. And I'm going to talk about what we're doing for that, for the automatic video categorization using our training set. So we're currently in phase 3 of our project. So in the first phase, phase 1, we did deep learning for automatic video categorization. So this was just looking at frames of videos and using convolutional neural network, Inception V3, if you're familiar with that one, and using that to categorize a video as either science or not science. So it was just a binary classification problem in phase 1. At that point, a lot of our videos were in the science category, so we were able to get a pretty even data split between science and not science. So that was one of the reasons that we chose to do it that way. Phase 2, we looked at audio features because video is made up of both images and audio. In particular, our editors have reported that they're able to categorize a video if they only listen to it but don't see it. But it's a lot harder to categorize a video if they can't hear the video and only look at the pictures. So we thought that analyzing audio features would be a logical and potentially really rich feature space in order for us to do automatic categorization. So that was phase 2. And we're currently in phase 3. There's 3 parts to phase 3. The first one, we want to combine audio and visual features. So there's a lot of richness that can be had like by combining both modalities, because a video is made up of both modalities. So that was a logical first step. The second thing that we did is we expanded the problem a little bit, or a lot actually. So before it was a binary classification problem. Both phase 1 and phase 2, we just looked at science versus not science. And now we have 16 categories. Science is one of them. We also have education, news, geography, politics, health. I can't remember them all off the top of my head, but we have 16 categories in total. And it's also a multi-label problem. So each video could have more than one of these categories assigned to it. And before I talk about the third part of phase 3, I'm just going to talk a bit more about multi-class, multi-label classification, because it's actually really tricky. Okay, so we're all data scientists, so we're probably familiar with binary class confusion matrix. It's very simple. You've got your predicted classes, and so what your classifier predicts for the class, as well as what the actual classes are. And so, you know, if they predicted it correctly, that's a true positive. If they predicted a positive case and it was actually negative, that's false positive, and etc. And you can use this kind of confusion matrix to calculate recall and precision, F1 scores, and get metrics of this type based on the confusion matrix. I like confusion matrices myself just because it gives you an indication of how your predictor is actually doing and what it's getting confused by, rather than just like an overall kind of accuracy metric. Okay, so moving on to the multi-class problem, because we have 16 categories now. Multi-class confusion matrix, basically, it's also pretty simple. The main feature that is worth noting is that your classifier is doing well if the highest numbers are along the diagonal. So if it's guessing the true class for every sample. Now, before I go on to multi-label, there's actually, it's tricky to make this jump from multi-class to multi-class plus multi-label. So this is actually an example of multi-class without multi-label. There's only one correct answer. In the case where there are multiple labels, it's a lot harder to get a sense if the classifier got the wrong label, did it get it like half right? Getting one of the two labels? Did it miss a label? Did it add another label that it shouldn't have? So making a confusion matrix for that is actually really hard. So if you try to do it using a built-in function like from sklearn, what it's going to do for multi-class, multi-label is it's going to turn each label into a binary classification problem. So you're going to have, in our case, you'd have 16 separate confusion matrices, and it would treat all non-labels as the same thing. But for one thing, this is really confusing to look at if you just look at 16 confusion matrices. So the other thing is it's confusing to look at, and it also doesn't really tell you if there's consistent labels that they get confused, because every incorrect label is treated the same. So fortunately, when we were starting to do this, a paper had just been published that proposed a method to distribute these incorrect predictions to other classes equally, but then to add them all together in a way that it basically makes one confusion matrix that's a 16 by 16 matrix. And it fulfills all the same criteria as a regular non-multi-label, multi-class confusion matrix, in that, like, if you look at the diagonal, that's where, like, you want to see the highest numbers. But then it also gives you a sense of if it's getting something consistently wrong, what is it normally confusing it with? So this is really helpful. And you can also use this to calculate precision recall F1, just the same as a regular confusion matrix. So we were really happy to see that paper and be able to assess our classifiers with this. Okay, so the third part of automatic categorization is incremental learning. So this is where the partnership between human and machine really takes place. So up until this point, we're just using machine AI classifiers in order to make these predictions. But we really want to support our journalists because they're the experts. They're the humans who are capable of, like, creativity and critical thinking. So that's why we're doing incremental learning. So with incremental learning, basically, we have a partnership between the categorizer and the journalist or the editor. So the categorizer will download and make a first prediction of the categories of a video. And then it will send it to the journalist, and the journalist will check. And if it's missed a category, it can add those categories in, or if it's made a prediction that's just really weird, it can take that, the journalist can take that category out. Another possibility with this is that if the machine makes a prediction that the journalist wouldn't have thought of naturally, it could be food for thought. Like maybe there's something to this. Maybe it's worth considering that a particular video is actually politics, even if that wouldn't be the first thought of the journalist, because people can get into thought habits. This is just how people work. So it could be a good kind of check and balance between humans and machines in actually getting a really good classification for a video. So yeah, once the journalist has provided their final assessment of, like, the actual categories for a video, that's sent back to the categorizer as well. And then incrementally, the categorizer can use this feedback in order to improve its future predictions. So that's what we're currently working on with Seneca College. Okay, so I've talked a lot about categorization. And now I want to talk about what we're doing with recommendation. So basically, as I said at the beginning, the problem with recommendation is that it can often drive people into bubbles. So at Vubble, we really want to create an algorithm that recommends really good, interesting, engaging content, but that helps pop or at least nudge people out of their bubble and to consider other viewpoints. So we've built the Vubble recommender engine, which is a hybrid model that incorporates both content-based and collaborative filtering recommendation algorithms. We've also done our own addition, which is this bias spread algorithm, which is what we use to do the diversification, making the content not just pull people into bubbles, but show them new, surprising, serendipitous content as well. We've done some validation of this through a partnership with Sengen, so we were able to do some load testing of this. And as a consequence, we've now deployed it on Kubernetes in order to be able to handle this load and really parallelize our system to handle large numbers of users. Okay, so let's talk about the recommender engine. As I mentioned at the beginning, one of our values is explainable AI. So we don't want a recommender engine that's just a black box, or in this case, a blue box. So let's take the lid off this box. Let's see what happens, how the machine comes up with recommendations for individual users. So there's basically three parts. There's a data pre-processing step, loads in the data, and puts it into a format that our algorithms can use, that our models can use. Then we have our models, and as I said, they're collaborative filtering and content-based filtering. And they both make recommendations which are fed into our bias spread, which combines the recommendations. Okay, so you might be familiar with content-based filtering and collaborative filtering, but in case you aren't, here's an example of how it works. So content-based filtering is great because you don't actually need to know all that much about a user. All you need to know is what they explicitly say they're interested in. So for instance, if someone is interested in business, then we can give them videos that are business related. And if they're interested in culture, then we give them different videos that have more to do with culture. Collaborative filtering, basically, it can be really good and really strong for personalization, but you need to have a decent amount of information about what the user has actually watched. And so for that, we need to gather a user history and see what kind of videos they actually watch. They might have said they're interested in politics, but then they end up watching all sorts of videos about science. And so then you can get a more accurate assessment of what they like. And when you can, so when you have this sort of system, the collaborative filtering, if you have a user with a certain history, you can compare their history with other users' histories and use that to make predictions about what they want to see. So we want to use both of these because content-based filtering is great because you don't need to know that much about the person, but collaborative filtering is great because you can be much more accurate and have much more powerful recommendations. So basically, you want to be able to use both of these systems. So a lot of existing recommender engines are probably hybrid systems that combine aspects of both of these algorithms. And so we combine the output of our collaborative filtering and our content-based filtering models into our bias spread algorithm. So there's a couple of goals. Like I mentioned earlier, we want to combine the output, so balance the contribution from all models. And this is you can set this. It's configurable. So there might be different situations where you want more recommendations from a certain model than another, and so part of what the bias spread algorithm does is combine it in this configurable way. And second, we want to pop the bubble, so we want to maximize the diversity of recommendations. So if someone says they're interested in politics, we don't want to just give them 20 videos about the same recent political scandal. We want to make sure that we have different stories that are covered, different perspectives on that story, as well as different things entirely. in order to really push people out of where they would naturally be. And that gives us our final list of recommendations, which we can then send to the user. Okay, so I mentioned this engine load testing, and yeah, that was a really helpful partnership. They were able to provide us not just with really fancy machines that we wouldn't have had access to otherwise, that we could run these load tests, but they also provided us with some technical expertise and guidance. So that was a really great collaboration. And yeah, so now we've deployed on Kubernetes. And if you don't know what Kubernetes is, I didn't know until we did this load testing, and they were like, why aren't you using Kubernetes? So basically, Kubernetes is a really great way to handle different demands of load at different times. So if we have a sudden rush of visitors, like maybe if you all, I don't know how many of you there are, but if you all go and check out our product after this, and we suddenly have way more people using our system, Kubernetes is able to allocate extra resources for us and handle that sort of extra demand. It's also really good for parallelization, which, yeah, again, has to do with handling additional load. Okay, so let's take a look at the discovery box. I've talked a lot about algorithms, but let's see how this all works. So I'm going to go to our website. Okay, so if you go to our website, bubblepop.com, and scroll down the page, you get to our discovery box. And by default, there's no AI. So what you're seeing right now is just kind of an AI-less version of content-based filtering. So you can select different topics that you're interested in and see videos that have to do with that topic. But you can only select one at a time. So if you're interested in science, technology, and culture and entertainment, there's no way of combining those. So ideally, if you want to have a way to do this, you come over to the AI toggle and you toggle that on. So you can select what topics interest you. So this is what feeds the content-based filtering algorithm. So you can select as many as you want. Let's do politics and business. And then the other thing you can choose is whether this is the tone selection. So whether you want to keep it simple or whether you want something like really difficult and heavy to watch. I want to keep it simple, so I'm going to put it up here. And then you just recommend videos. Okay, so I said politics and business. So let's see here. So we have some business. This was, yeah, I saw that one earlier. Business. Definitely looks like it's a lot of business. Here's a politics one. So if you want to watch them, it opens up in a new video modal. You can watch the video. You can also, if you liked the video, you can provide us some explicit feedback. You don't have to. We do also keep track of videos that a user has watched in their history and use that to inform the collaborative filtering. So yeah, these explicit and implicit signals are what we use for the collaborative filtering. So yeah, I'm going to give this thumbs up. And I mentioned the credibility meter. This is how it would look. So we have these 5 criteria, and it looks like this is a pretty credible video. It's PBS, so it's going to score high for author credibility because PBS has a history of providing trustworthy information. It looks like it scores lower on citation or data, so this might be something, maybe it's just covering one point of view. But yeah, that's our credibility meter. So this is how it looks on our website, but for our other customers, this is completely configurable. So if they don't want the credibility score, that's like we don't have to show that. AI could be enabled, could not be, though of course we'd like to enable AI because it's so helpful. Okay, and when you're done, you can go back and watch other videos. You can get more recommendations. The more a user watches videos and interacts with them, the better and more personalized recommendations will be. All right. So let's discovery box demo. Okay. So this is just, yeah, that was also about the discovery box. So I also mentioned that we have a smart email. This is still in beta. So if you want to sign up for it, we do have a regular non-AI email that you can sign up for, and we will eventually be moving that, our beta, into general testing. So basically the smart email, it works along with the discovery box. It also provides personalized recommendations, and it plus some editor selections. So we have a category called best of the day. So every day our editors select some videos that they think are really important and deserve to be watched by a wide audience. So that also can be sent directly to your inbox. Definitely there's the benefits of using a smart email is that from a user perspective, it's more of a passive kind of system. Like the recommendations come to you rather than you having to go seek them out. Yeah, you can get personalization rather than just something that's sent to every other user of the system. Okay, so I've talked about a lot of things. So what we do at Vubble, we categorize and assess information video on behalf of news and educational organizations. We use journalists, experts in these domains to assess the videos, and we've built up a huge information video data set with lots of metadata. And we've used this data set as part of our development of automatic categorization algorithms, but we haven't taken the human out of the loop, and the human is still a really important part of our curation and assessment of videos. We've developed a recommender engine that uses a hybrid of different algorithms and does it in a way that aims to not fall into the trap of polarization, but instead to pop people's news bubbles. And finally, we have a couple of products that we use for distribution, Discovery Box and the Smart Email. So that's it for me. Feel free to reach out if you have any ideas for collaboration in particular. We're always really interested in collaborating with people. As I mentioned, we collaborate with Seneca College and Sengen, and we want to collaborate with other companies and other academia researchers. So yeah, drop me an email or reach out on LinkedIn, and I'll be really happy to chat. Thank you.
Thank you. That was wonderful, Mariah. I really appreciate it. You had very thoughtful, insightful comments and arguments throughout the presentation. I was jotting down a few questions while you were talking, and only to yeah, sorry. Yeah, no, I was saying that later on I realized that you had answered the questions that I was going to ask. So it was very well put together, very thoughtful, logical arguments. So I have a few questions. If anyone is watching and has any questions, please type them in the chat. So I would read them out and be able to ask those questions to Mariah. But I did have a few things that I would like to get a little more clarity on. So you have a recommendation engine. It seems to be fairly sophisticated and powerful. And of course, coming up with recommendations for videos is not that easy a task to do. So in terms of the cold start problem, so when you were giving the demo of the Vubble platform, you had an individual who joined the first time or came and started watching videos the first time. So typically they would not have a lot of history in terms of their persona, their personality. You may have some demographics about them that may be used for the engine, the recommendation engine. But how would you, in addition to, assuming you don't have anything, how would you deal with the cold start problem? How would you be able to give a personalized recommendation if you didn't know a lot about that individual?
Yeah, so that's definitely an issue, and we do hope to have longer term users for that reason, because basically, yeah, when a user first starts using the system, we have to rely only on the content-based recommendations. So that's just the categories that they select. So those categories, those are just our examples. I think there are 5, but we can have up to our entire 500 plus categories available. So the hope would be no one, it's less likely that people are going to put the exact same preferences in when they're starting up if there's a larger number to choose from. And that is taken into account during the content-based filtering, because everyone's preferences are probably a little bit different from everyone else's.
Yeah, they would be. Yes, I agree. And the Vubble credibility meter seems to be rather intriguing. It seems to be a significant innovation, particularly in this day and age where we have a lot of false news going around, and there's a lot of fake videos which are created, especially to politicize certain events. Could you tell us a little bit about the credibility meter beyond what you showed us? It seemed to be rather intriguing. And how are you going about coming up with that credibility meter in terms of the categories that you had? I know you had a few measures based on which that credibility meter would give a score, for example, of 94. Could you tell us a little bit about that?
Yeah, so that's more of an editor thing. I think I might be able to find how the scores are generated, but it's not something that I've worked on myself. But let me see.
Or just at a high level, explain what the credibility meter is.
Sure.
Is it a measure of how trustworthy the contents of the video are going to be?
Yeah, it's designed as an educational support. So we want to basically direct people's attention to sources. So where did the video come from? Does it cite its sources? Whether there's emotion or bias in the data or in the video. So often when videos are more emotional, there is more bias. So that's one of the factors. Whether they actually presented data or if they just presented people's comments and opinions, that's another factor. And then also the history of the publisher, like I said.
Okay, that is fabulous. Yeah, in this day and age, we definitely need that. We definitely need to know whether a video comes from a credible source, whether it's from a trustworthy source, whether it has, as you mentioned, emotion in it, which would often skew the contents. We have a question from one of the participants. Let me just read out. Okay. So thanks for the great talk, Mariah. I have a question. I like the idea of diversification of content, but I have feeling that part of the bubble problem is some users want to stay in their bubble, which is actually a very valid concern that we don't often want to be exposed to new thoughts and ideas. So the diversification is a negative user experience. How is that balanced? How is the balance keeping content diverse and having good experience done? So do you? So I guess the question that is being asked is, do you add a little more intelligence in the recommendation system based on the persona, based on the profile of an individual, that certain individuals would be more open to experiences or ideas from other videos, whereas other people would want to be more confined to use the term bubble in their own bubbles?
Yeah, that's a really good question. And I think we're still developing this. So we have, it's definitely true that people who score high on openness to experience are more likely to welcome these kind of surprising and serendipitous recommendations. It's definitely a challenge because we don't want to collect this information, this personality information from people without their consent. So yeah, that's definitely a concern. And we have designed it so that we can potentially have different balances of this, but it's not currently implemented. But yeah, that's definitely something that I think about a lot.
Yeah, you're right. And it's like one of those classical problems. How much of personalization do you do, and how much of additional things do you bring in from the outside world? Now, there's another question that I want to ask. So, data privacy is something that is being taken very seriously. It's something that a lot of people are talking about. How is data being used? You talked about the Cambridge Analytica scandal that Facebook was involved with. We've all heard about that. It was a huge disaster for Facebook. So considering that data that people are, so if I'm watching a video, I do understand that there is probably some analytics that is being done behind the scenes, probably to make things a little better. But beyond that is something that I might not be comfortable about. So could you tell me, how do you handle user privacy when you're tracking all of the videos that are being watched?
Mhm. Yeah, so basically it's kind of an opt-in system. Um, when you provide the information just through our website, that only is saved for the length of the browser session. This is why we want to have the smart email be more widely used, because that if people give us their email, we can also ask at that point, like, do you want, I mean, it's sort of implied, but we want to be explicit about, like, we'll be tracking your history over the long term and using this only for giving you better recommendations. And that's part of a kind of a informed consent process when people sign up for their email, for the email list.
Yeah, that does make a lot of sense. It's always nice to ask users of that, as you said, explicitly ask them rather than assuming that they are comfortable with something. So that I agree is a good way of going about it. And another topic that is very topical these days, that there is, one of the themes that is going around is explainable AI. So there's a huge push towards, trying to understand why things are the way they are, particularly when it comes to AI. When we're talking about recommendation systems, why are certain recommendations being made over others? So there's a lot of concern around how these recommendation systems work. There's worry that there may be inbuilt biases into these algorithms. So, is it something that Vubble thinks about, or you think about? How do you show your details of the algorithms to the users, and around the topic of explainable AI?
Mm-hmm. Yeah, so that's something that we have built into the back end of our recommender. It's definitely possible. It's not currently implemented, but to see along with the actual video and the description, to also see what model made that recommendation, what its score was, whether it was like a highly confident score or whether it was kind of just guessing. And so that's one of the things that we're talking about implementing, is this sort of, this is why you've gotten the recommendation information along with just the actual video.
Okay, yeah, that makes a lot of sense. It's not more. It's a lot more than a simple black box where you're throwing in some data and you're getting a recommendation and you don't know why that recommendation was generated. Yeah, it seems to be a very well thought out solution. And I have one final question from my side, and hopefully, if there are any more questions from the audience, we'll raise them as well. So in your research with Seneca, why did you only use 16 categories, for example, as opposed to all the 500 plus categories? Was there a particular reason for prioritizing these 16 categories over others?
Yep. Yeah, because 500, it's a pretty big jump, even from 2 to 16. 500 would be much more difficult. So we wanted to reduce the number of categories. We initially tried it with 40, and these 40 categories were determined just by the most commonly appearing in our data set. But even that was more of a challenge than we could actually get the algorithms to work with. So we have a process that looked at the correlation of categories and tried to find basically the most common and the most independent categories. And we whittled the list down to 16. And we're getting pretty good results with that now.
Yeah, I can imagine, especially when you have a video, which is by definition much longer than a simple picture, for example. So it would be easier to categorize and label and associate tags with a picture as opposed to a video, which would be a lot more challenging, because in a video, lots of emotions happen, lots of things happen in the video. So, yeah, that means imagine. Okay, so there are no more questions from the audience that I see, and I think we can conclude right now. But this was a fascinating topic. Honestly speaking, I'm generally familiar with recommendation systems, but I've seen them used in certain areas. For example, matchmaking, for example, product selection or product recommendation, what movie to watch, but something around recommending, categorizing, cataloging, and then recommending videos. It seems to be a far bigger problem than one would have thought. So this seems a pretty cool stuff that you're doing at Vubble.
Yeah.
And yeah. But very insightful talk. Thank you for coming. Thank you for this session. If hopefully these slides will be available to share. The link for Vubble that was mentioned in the slides and the session, I'll make sure that I put that in the description below. To our participants and our audience, thank you for joining live. And hopefully you'll be able to get a chance to see this platform in action soon. Oh, we have one more question. That's good. Let's go through this last question. Okay. So how good is the precision of audio compared to video categorization? Yeah, that's true.
Mm-hmm. Yeah, that's actually an interesting question, because, like I said, like the editors, for them, audio provides much more precise categorizations than just video. I think in general, audio as well is better for the machine. But one thing that's kind of interesting is that we have 16 categories, and for some categories, the video is actually better. So this is another reason why it's good to have a combination of both audio and video features, because they both have different strengths at different categories.
Yeah. And do you reconcile the categories between both of them, or even if you have contradictory categories coming up in the video, are you able to reconcile them in some manner?
Yeah, that's one thing that we're working on, is trying to develop, whether it's majority vote or some other strategy, we're trying to figure out what's the best way to combine the predictions from the different classifiers.
Okay, yeah, interesting. This is great stuff. And presumably this is something that you'll be, I don't know, in terms of business model, is it something that is going to be licensed to other platforms who wish to have a video categorization and recommendation platform?
Yeah, so we haven't exactly figured out what, we're definitely going to be using it ourselves, and we're definitely going to have a paper coming out. Well, we're applying to conferences now for a paper that explains our system. But yeah, we're definitely looking at uses for it outside of our company as well.
Okay, great. So this is great. Thank you, Mariah, for coming over. Thank you to our audience for being part of this live event. So this was the Data Science and Data Engineering series, where we talk about topics pertaining to data analysis, data visualization, data security, data platforms. It was nice of you to join. Please subscribe. We need all the support that we can get so that these sessions can continue on in the manner that they are. And I hope to see you at a future event. Thank you, everyone.
Thank you.
Bye.